Hello everyone, this is Anzar Kamdar, the Chief Decision Scientist at ThroughPut. Welcome to the cycle time demo for the ThroughPut Lite self-service diagnostics platform. For today, we will be choosing cycle time as our main KPI. I have a file ready here. If you don't have this file ready, don't worry about it. You can actually go into SQL Upload and select one of the sample data templates provided. Once you've done that, you can actually come back and see how the file is configured and which columns and categories to use. So the first thing that any tool would do in terms of this analysis, or what a data analysis or a data scientist would do, is just look at the basic statistics. So in this case, you're looking at the different spreads, the mean, the standard deviation, the min, max, the coefficient of variation. You could look at it by process ID or tool ID. You could look at different correlations, for example, and you could add, let's say, what based on the day of the week does the cycle time change. You can look at these correlations and you'll see that, for example, cycle time is very highly correlated with process ID as well as the tool ID, but there's no correlation between day of week and the cycle time. This is all fine. Eventually, you want to look at industrial statistics and see what's in control and what's not across all your process IDs, where you can look at the worst, best, average cycle times across the different processes, the different tool IDs, look at your capacity, look at your throughput, your utilization. Now, you can also just go to basic visualizations if that's simpler. You could look at all your average cycle times across the different processes. You could look at it across your different tool IDs and see what's happening. But most importantly, you should focus on the insights that are provided. Here, what you'll see is the processes that need immediate attention because they have a variability issue, processes that require long-term attention, and finally the stable processes. They may have very high, average, and worst cycle times, but they may be quite relatively stable according to the process design capabilities. You could also look at it for the tools, as I mentioned. Finally, you should go into your root cause analysis, where you will actually see from a statistical process control which processes are the most unstable. You could sort by the ones with the largest amount of large shifts or small shifts. Once you click into a specific process ID, you'll see the number of violations and how many points are out of control. And you could see the reasons for that as well. You could see it's because of a wrong setup, it's because of a power failure. The more information you put in here, the better the analysis will be. Finally, after you've decided where to focus on your areas of potential improvements, which tools or processes those should be, you move towards the action plan. The action plan is in two buckets. One is on the quarterly action plan that's focused on reducing variability for these highly unstable processes, where you're given both what the current best cycle time is, worst cycle time is, and then the bands that you should be aiming for from a target perspective. For the yearly action plan, it requires on focusing on reducing average cycle times. What this means is that this will most likely require some sort of investment or some rework of the process itself, rather than the quick fixes that you could do just by improving the variability. Finally, you can get into the financial analysis. From here, you can see that your current production is, let's say, 25 million. Without any cycle time reduction, that's what your target is. Now, improving the amount of hours that you work, you're able to push 30 million by adding more overtime hours. But let's say that's not possible due to some sort of labor constraints or unions. Now, from a cycle time reduction perspective, if we're able to reduce 10% cycle time at some of your worst bottleneck processes, you're able to push to 28 million. Let's say we aim for something more ambitious with 25% cycle time reduction. You're pushing closer to 34 million, and if you are able to add in just a bit more overtime, you're hitting that 40 million target. Of course, there's more things that you can play around with here in terms of your factory assets. You're able to quickly calculate the return on investment and the return on your assets by doing these sort of improvement efforts. Thank you so much, and that's the quick cycle time demo.